I have this. Oh, man. Yep, I had the mute button on. That's what happens when you switch your microphone number. I was always microphone 1, Missa was microphone 3. The other day I switched it, and now I'm paying attention over here, and I had the wrong microphone on mute. Wow. That's pretty pathetic. Can we start over? Fantastic. Well, that was a lot of talking for nothing. I guess I got to start all over. All right. Well, hello, everyone. Welcome to the show. Thank you for joining me. Sorry that I screwed that up. Like I said, I have my microphones always in the right configuration. This time I switched them, and I looked over, and sure enough, I had what I thought was Mrs. Mike on mute, and it was mine. So I'm surprised you didn't hear something, though. Does Mrs. Mike not pick me up? This other mic was on. But you couldn't hear anything, huh? I don't know if I should go over all that again. I guess I will. All right. Well, welcome to the show. Hello, everyone. Thank you for joining me. I appreciate it so much. A special hello to all those in the chat and all those at home or wherever you may be. I do apologize for that. That's no fun. And a special shout out to all those down in the Southern Hemisphere. Thank you so much. We appreciate you taking one for the team and taking all the upside down jobs. Appreciate that. Don't want those myself, so we'll call you guys sloppy bottoms down there. And I saw Iru in the chat earlier. He's the head of the sloppy bottoms down in the Southern Hemisphere. The old SHers. That's what we'll call you. So, okay, now I have to rethink my thoughts here. And I went on a tirade, an absolute tirade, and nobody heard it. It's actually probably a good thing because it was completely off the cuff. And, man, it was pretty heated. I just had words for whoever is doxing flat earthers, and it was out of nowhere. And so you're probably lucky that you didn't hear it. But I just was saying that I can't imagine having such a pathetic life, that I did things like that and put other people's lives in jeopardy, and didn't have a care in the world for people with families and people with friends and parents and sisters and brothers and children, and to put people's public info out in public like that, or put people's private info out in public like that. How do you sleep every night? I can't imagine, because you must think you could be responsible at any time for the injuring of somebody else. I just don't know how that's even in somebody's mind. And, I think that ultimately we will be, judged in this life by how we handled the life we were given. How appreciative of it were you? Did you promote freedom and justice and harmony and peace and liberty and love? Or did you promote hate and doxing people and just being a dirtball overall and putting other people's lives in danger and not caring and being so upset by the flat earth that you'd put people's lives in danger when people are just simply using their freedom of speech? Not requiring anybody to listen to a word I say, not requiring anyone to pay me a penny for a word that I say, and yet somebody has such a problem with it that they will put my personal address and phone number, and and I've got a wife and kids. Don't care so much about myself, but pretty pathetic. And it really just shows me how scared somebody is, how frightening they are of the flat earth being true. And if it was so dumb, if it was just nonsense, then you'd leave it alone. Why would you even care? Why would it bother you? And not just bother you, but bother you to the point that you put people's lives in jeopardy. Just baffling to me. So, whoever you are, you're a dirtbag. I'd like you to know that. And, keep making sock puppet accounts and doing what you're doing, because that's really the ticket to a fantastic afterlife. Because I really do think that in the end, we might be, just like you weren't in existence before you were born here, like you can't remember that. Well, it may be the same thing, that, if you treat life in a way that shows that you appreciated it, that maybe you're given another. Not necessarily on this earth. I don't think that you come back here, but maybe somewhere else like this. And just as many people think that the earth is all there is, when you don't believe in the crazy spinning galaxies and endless upon endless quadrillions of light years of space, then you understand that this is a pretty special place, that you are the center, and that everything is focused on this. And maybe there's another existence just like this, but I'll promise you that the people who shit on other people's lives and the people who put other people's lives in jeopardy and did dirtball things like doxing, and those people are not going to get another go around because they're going to get what they wanted, which is the opposite of life. They're going to get death, and that's going to be your final time closing your eyes. So again, that's just my opinion. I'm not saying that that's the case, but it's certainly better to live your life like it is. Certainly better. And then you take that chance at possibly coming back and maybe getting better and learning from your mistakes. But some people out there just refuse to be a good person, and I certainly don't think that they will be around to do it again. So anyway, let's move on. What I wanted to say was we're going to do two things tonight. Number one, we are going to go through real quick the force the line experiment. And just to let you know, the experiment will not be happening, mostly because it's really not feasible. The price of that experiment would be far too high, talking about at least 6 digits. To fabricate the pieces needed by a machinist, and the amount of them would just be cost prohibitive, and plus any kind of fault in the setup at any point, a little eighth of an inch here or quarter inch here, would render the experiment void, and we may not even notice that it happened, and then we go all the way down, and that would just grow exponentially. It would get worse and worse, and we wouldn't even know it really. So let's rethink that, and we're going to go through some people's comments, but I'm going to kind of skip through the ones that were about the force line. The Google Sheet is still open, which is bit.ly, bit.ly/force align. And I'm going to keep it open. If you have other comments about force align, you can put them in there. And then also, if you've got any comment about the experiment that I'm going to discuss in a few minutes, then please put that in there, and we're going to just kind of work together to get the best experiment that we can. For me, I don't want to do anything that involves optics. It's just learning is too subjective for now. I know, not saying anything bad about those who are continuing to do them or anybody who wants to do that. You can do whatever you want. But for me, I just don't want to get another Salton Sea where it's, optically it can be either or. I could see, nobody changed their mind because of that experiment. So what is the point of that experiment? However many people watched it, however many people were down there, I'll pretty much guarantee not one flat earther became a globe earther and not one globe earther became a flat earther. So that experiment can't have been the best method. So I do want to find something that will change some minds, and we'll look at that. And some people had some ideas, so we're going to bring up this little spreadsheet here and take a look. I did delete a bunch. I also answered a bunch or responded to a bunch via email. So you either got a response from me, you got deleted, and if you're one of the people who just uses this to cuss me out and then not leave your email address, real impressive. That's pretty scared of that tough guy, whoever he is that does that. So let's see here. Questions. Somebody says here a lakeshore of confirmed size. I totally agree that we want to get next to water. Just makes everything a little bit easier. So that's definitely going to be in the works. Somebody here says that they thought that the original Brian Mullen had the level control as the lower line. Yeah, and we're not going to do the Brian Mullen experiment. So we're going to move on from that one. And yes, they said the same thing, that if we mess up a little bit, that it would grow exponentially. Totally agree. This person, same thing, is talking about not using metal, possibly using wood. So we're going to move past that one. They say do it on a sandy beach. Person says do it on a beach. This person says make the individual lengths for perfectly straight parts as long as possible. One example, about 50 times more accurate than the one you bought. Huh? So I'll take a look at this one. I guess I didn't see this one. If you connect properly, a gap may appear. Oh, yeah, I did see your drawing. I did see this one. I did respond to you, too, I think. So this person here says, lots of people with P900s spread out for miles in, say, Kansas, each one being able to see the next one, and so on. So that's not a experiment and would be possible on a flat Earth or a globe. So don't think that will necessarily work. If I'm misunderstanding your idea, then you can use bit.ly/forceline again. This person here says, take 2 boats out in the middle of the ocean. Each boat will have 500 miles of rope or cable. I'm going to go ahead and stop there. It's probably not a doable thing. And if you're talking about, do you talk about pulling the rope and, yeah, that's not going to happen. Stretch rope tight, measure, no, that's not a possible thing. You probably couldn't do that for 500 feet. Put an astronaut in a spacesuit. I believe somebody's trying to do that. Last time I heard, Mark Sargent or somebody is trying to get somebody in a spacesuit. I'm not sure who. Get 3 or 4 miles of strong yet cheap wood. Come up with a mechanism to lock. No, it's not. It's not going to work. It's just there's too much room for air, and over 2 miles, it's just too big of a distance. I kind of overshot my wad, but I was thinking that because Brian Mullen came up with it, and he's an engineer, but I think maybe down the road he kind of realized that it wasn't going to work. This person says what to do here. Again, the structures that'll be aligned and not leveled will be affected by weight, which won't work. Okay, so I agree with that person. Repeat the test of Eratosthenes and prove the sun's angle is the same no matter where you are on Earth. That is not a true statement. So don't want to be doing that test. The sun's angle is not the same no matter where you're on Earth. Similar to force a line, but install pipe that is leveled the whole 2 miles. And if you can see through the whole distance, it isn't curved after 1 mile, that 2 to 3 inch pipe. Interesting. I don't think you'd be able to see it anyway just because of perspective. That's a great way of looking at perspective. If you look through a pipe, you would quickly limit the amount of light at the end of it. And after, I would guess a football field worth of tubing, you probably wouldn't be able to see through it. Let's see here. This person says 2 suggestions. Incorporate laser levels. Talk to Bosch and other dealers. Make a computer program to track the sun's movement. Position the fence on the exact latitude so that deviation left or right could be measured if it's an AE style layout. That's tougher than you think. We don't have the lines of latitude painted on the ground or anything. I wrote earlier about the lasers and my land. So this guy's got some land, a couple acres that he was thinking we could do something on, so I'll contact him. Make it longer than at least 4 miles so it's clear. Obviously, 6 foot of drop. I agree. We want to go as many miles as possible within reason. I think force line is something that people who never worked in construction would dream up. All right, well, talk to Brian Mullen. He's an engineer, and I'm sure he's worked in engineering. Make a plane of 100 acres. I don't know what this might be the same guy with this little land. So, yeah, there wasn't a lot of unique experiments that I saw. So, again, still asking that question. We're looking for something that is not optics, that cannot be argued away with simply, well, I think it's refraction, well, I think it's hazing, and I think it's looming, and I think it's mirage. That's not going to cut it. Again, we want to have people walk away and at least feel like they learned something or saw something, So this person says likes to force the line, but it won't settle Glober's mind. I totally agree. So we have another experiment in mind. This one says, fly from the east coast to the west coast with an inertial measurement unit without correction. I still have questions about the accelerometer. Yeah, I really got to think about that one because Bob and I, for a while, were really looking at that, and I have a hard time believing that doesn't prove it in and of itself, but got to do some more research on that. I could be wrong there. Let's see here. My idea is to dig holes at the beach, high enough on the beach so that the oceans don't interfere. Dig a hole every 50 meters along the beach and ram posts in at a certain level. You measure the theodolite. Yeah, I don't want to do anything with a theodolite, and I'll explain that why. And this is probably one of the tougher things for people to come to grips with, is that they don't measure reality. And I'll show you what I mean by that shortly. I've had the force the line idea since the first week I heard of Flat Earth, which is only about, can't read the rest of that. My idea is called Mile Long Aquarium. Fill a 1 or 2 mile long concrete wall. Level ground would be helpful, but not necessary as long as it's mostly flat. Step 2 would be to take sheets of glass or plexiglass and cut them into long, narrow lengths about 2 to 3 feet wide and construct a short glass wall parallel to the concrete wall. Okay, I'm trying to get this. Okay, got you. The glass wall could be short, like 2 to 3 feet wide, to save on material. Now we have a 1 or 2 mile long, 2 to 3 foot high glass wall parallel to the concrete wall. The two walls can be very close together. Within inches, we could close off the ends and would then effectively have a 1 or 2 mile long aquarium. Okay, I'm with you. Eventually, we'll fill it with water, but first we must create our force line. I think we should create 2 or more force lines from different sources. Yeah, if the force line is what's going to be tough. The methodologies of forcing the line can vary, or we could simply trace the lines onto the glass. I think it would be easy as using the tight string method for 20-foot lengths. Now, that's interesting. That's interesting what you're saying there. Overlapping each other at the midpoint for accuracy. So you're saying rather than force the line, we use some sort of a drawn line. Yeah, it's still going to be tough. I still don't know how, unless we had like one solid piece or something. If you're having to add piece on top of piece, any kind of change in that, even if we overlap. Ideally, all force lines will support the accuracy of each other. I'll check into that one and I'll email you and see if you've got more ideas besides that. But I do think that maybe, I don't know. Okay, let's see here. Placing perfect vertical posts again, perfect. Anything like that it's just not going to work. Using a laser instead of checking the top with beams, lasers can be off too. They can, there's a lot that can go wrong with lasers. Do it on a frozen lake. You have a knowingly flat level surface, and you could, one thing that's interesting about, just what I've heard recently is I always thought that colder was the best time to do it. But, when you see this website I show you in a little bit, I saw today that actually cold weather, because it's more dense, causes more refraction. So warm weather causes more of that haze, that kind of a wavy look, but that cold weather causes more refraction. So I never really realized that. All you need is a long, thin, clear tube filled with water to be used as your level. Okay, maybe. I like the water ideas. I just haven't seen one yet that would work. As you can use it to make posts, can be 20 feet or more apart or have far less posts. But best way is you don't have a laser, maybe even better because it's analog. Water always finds its level. Yeah, so I think I deleted about 10 entries. And let me show you a drawing because I don't think people are quite getting this one and why that won't work. So I had to read a couple of them a few times just to make sure. And I think I even mentioned a while back about doing that idea. But if you had a curved Earth, and here's the crazy thing of how they get away with this all and everything. But if you have an Earth like this and you've got any kind of pipe with water is going to conform to the center of the Earth, meaning that this surface is supposedly all level. So believe it or not, if you were to take a level, we've all seen levels. If you were to take one of those and put like a little level like that, we'll get a little green dot. So if you took a level and leveled it, all right, we're level there, and you buddied up levels one after another on top of each other, and even if you got them perfect, this is basically the thing that drives flat earthers crazy is you could get them like this and you put them right against each other and they're perfect, boom, and you go to the next one and so on and so forth and so on and so forth. That according to globe believers, after 25,000 miles, you will have gone around the Earth and come back up and met yourself here, even though your levels are flat and level. That the Earth curves so gently that you would never notice it from a 1 foot or 6 foot or 12 foot level at all. So that's where I think it's a metaphysical thing. I think there has to be more proof for me to believe something like that. You can't just tell me that things form spheres at the center. They pull mass, attracts mass, and that we're all attracted to the center of the Earth and we're all being pulled and it's all the same everywhere. It just doesn't make a lot of sense to me. If I build my house flat and level and the neighbor does and the neighbor does and the neighbor does, according to globe believers, you'll come back around after 25,000 miles and end up where you started. Sorry, 1 second. Need a drink. So that's kind of a crazy thing about the globe Earth. And, this is how again, the ocean in Australia is level with the ocean in California. Even one be upside down from the other. So that's why I just don't think that that's true. I just don't. Haven't been shown the kind of evidence that I think should be required for such a claim. They say extraordinary claims require extraordinary evidence. And I don't think evidence of boats being able to exist upside down, huge cruise ships are upside down. I don't think a good proof of that is the shadow on the moon. That's just me. It's not proof enough for me to say, yep, ships are upside down because the shadow on the moon is curved. Nope. Or because we see ships go over the edge, well, we really don't. We can explain that in other ways, so it's not as proof positive as people think. So there's not that kind of proof on either side that should make you just go, oh, well, there's no questions to be asked. The globe loves to look in the air and say, well, we see the stars do this, or we see this happen. And again, we're talking about the ground. So if you get a pipe and you were to pass it from this location to this location, a lot of people think that there would be a change, in the water level. But there wouldn't be. I mean, this water here is going to be technically level as it goes through here and here. So if this is 2 inches off the top of this pipe, well, this would be 2 inches off the top of this pipe, and they would actually be level according to globe believers. So I think a lot of people get confused. I saw a ton of people, more than 10 that I deleted, that were just some form of that experiment, and they didn't seem to think it all the way through, or maybe I missed something. So if you had a better idea if it was more than that and I'm just missing your point, again, bit.ly/forcealign, and tell me how we can, because I love the water idea. I also agree that water is going to find its level, but once you get that distance away, how do you make sure that that what what's actually going on is what you see? One of the things, so I told you I wanted to talk about real quick. Let's just talk about telescopes and theodolites, etc. So what people I don't think get, and the only reason I ever got this is because I read enough of Samuel Rowbotham at the very beginning, and I wanted to understand the Bedford Level experiment, and finally did. And what happened there is a case of, the other guy, and I can't think of his name right now. I think his name is John. Maybe somebody could put it in the chat. He originally came out with the video called Mountains of Evidence. And he basically went to the hills and was spotting a hill off into the distance and was basically saying that his calculations were coming out to show that the Earth was flat. So he went back and did some more tests on his channel. I watched one recently, and very clear to me what happened. He set up 2 half bottles of 2 liters, put some water in it, leveled his camera with that level water, and then shot his camera off in the distance. And let me show you an example of kind of what happened in his test. And I don't remember the exact figures, so we're not worried about that. I'm just going to kind of throw some arbitrary numbers in there. But he basically had a mountain over here that he was trying to see, and he was on a mountain that was about equal height or so over here. And he put these 2 things of water and then shot his little scope across. Well, or the camera across, and if you did that, from here to here, and you leveled it where you are, so you level it here, well, things in the distance shrink due to size, due to perspective, as well as go beyond the curve. So what he did is he kind of shot his level and showed that it was about to the top of the mountain, something like that, and the mountain was supposed to be 600 feet taller than the mountain he was on. And from that, he surmised that he's on a globe Earth. Or he kind of didn't say that. He just, I'll let you make up your own minds, but, I can't, there's no flat Earth explanation for this. And the flat Earth explanation is absolutely there. The flat Earth explanation is you shouldn't expect to see a mountain in the distance that's taller than you, higher than where you're at. That mountain has shrunk due to perspective, and therefore you need to account for that. So one of the things that people I don't think recognize, and it comes down to I don't know, when you tell people this, they can't possibly believe it because it kind of sounds like you're admitting that the Earth isn't flat, or that you have to make up an excuse for it. Because if you were to take a bunch of telephone lines, let's say, so these telephone lines are going off in this distance here. I'll draw a road there in a second, something like this. And they go off like this in the road. Okay. Probably a little closer there. Okay, so let's say we've got these going off in a road or street. There's our perspective line, something like this, and the little middle lines of the road. Okay, so if you were to take and these lines are not straight, sorry about that, but if you were to take a telescope and you were to level it at this position up here on the top of the telephone pole there, kind of blend it like this. All right, and so imagine that we're looking down this way, looking here. If you leveled that at this little pole here, that your line of sight for the telescope would basically do something like this. It would not follow the tops of the telephone poles down to the horizon. And many people think that it would. And it's understandable why you would think that, because it seems to make logical sense that if I level something, I know if I stand up and look level, the horizon kind of rises to my eyes, everything goes to the vanishing point. Therefore, if I have a telescope on my shoulder, it should do the same thing. And theoretically, at that height, maybe you'd be close to it. But when you start realizing as you got up higher that this, and here's the best way I can describe it. All that exists to the telescope is the circle of the telescope. Meaning this land here doesn't even exist. It can't exist. This telescope doesn't see it. It's looking in a cylinder like, this, where it exists. So all the telescope is doing is zooming in on that one circle, and that's not reality. And so, Slice Barkane and those guys and Soundly, they'll all laugh and joke, Jesse Kozlowski, because I say we have to tell the telescope that things get smaller with distance. And they hee-haw because they don't get it. And, I understand that they need a little bit more training to get it. But what happens is you have to aim your telescope at the first two telephone poles. And when you do that, the other telephone poles will fall in line perfectly. If they start to fall off that line, so if you start to aim that and then these telephone poles went like this or something, well, then the Earth is curved. But this is what happened at the Bedford Level experiment is, Samuel Rowbotham said, well, no, you guys didn't take that into effect. You leveled the telescope at the observer point and then said, things fell below the crosshairs. And he said, yeah, well, they fell below the crosshairs because you need to aim it at the top two or first two things and then go. So just like I just talked about, I think his name is John McIntyre now. I don't know if I got the name right. But when he did his test, he had 2 jugs of water. And my drawings are so bad, I know. It's just, sometimes I got to talk it out. So like I said, he had a mountain here way in the background. Oops, that was supposed to be a pen. All right, so he had a mountain way over here in the background. And he was on a mountain over here. So imagine that there's, miles and miles of space here. And he basically had these 2 jugs and was using those for his level. So he's standing over here. He's got this jug of water. And he's got another jug of water. And he's basically aiming his camera at these 2 levels of water and then aiming out here. And he thought that this peak should be above that level line because it was supposed to be taller than the mountain he's on. The problem with this is, again, that you're not taking perspective into account. You need to realize that things get smaller with distance, and the telescope or camera needs to be aimed accordingly if you're going to be measuring off that line. So, it's easy to see why things like geodesy measure the curvature of the Earth, because what they do, you've all seen them stand out at the road with their measuring tool. They got their little yellow, theodolites or whatever. And what they're doing is they're measuring basically the drop, because they're looking out this way, and when they see a little bit of a drop in the distance, they're calling that, they actually think that the item is leaning. So for instance, if this is your control point or your pole that you're looking, and it's dropped 2 feet in this distance, they call that curvature. They think that the pole, not that it's dropped 2 feet, but that it's leaning. And that's why they see what they call a zenith angle. This angle is less than 90. And that's what they're calling curvature when it's actually perspective. So, a telescope, a theodolite, anything like that optically is going to need to take into account perspective, and they are not made to do that. So they don't do that. There's also lots of optical errors with them, with spherical aberration and all kinds of stuff. So that's why, and I guess we'll talk about it now. We're going to get to it after, but that's why I think going back to my test from many months ago, where the only problem was that we didn't get a proper laser. We still don't have one that worked. It's a little bit more expensive than I think any of us wanted to spend or even consider, and we still have some options out. I know Mike Kavanaugh from FE Core is going to be testing our updated laser or our fixed laser after it broke, and he's going to check what the beam diameter is after 3.88 miles. We need to keep it at less than 3, so what I'm going to do is just lay out that experiment real quick for you, and you tell me either through bit.ly/forcealign, tell me what you think's wrong with it, and I'll tell you why I like it. And many people might say, well, you just said you don't want optics. Well, this is a little different than optics, because I think that it's not a matter, nobody can say, well, I saw refraction, well, I didn't see refraction. It's not quite like that. So there is a canal here close to me. It's about an hour from here. And For the most part, the water is always still. Never seen it rushing. It does have tide fluctuations, but never more than a foot, and you can actually time it so that if you're out there for like 8 hours, there's no change for more than a few inches. The way the tides work, you can schedule your time so that you're not being majorly affected. But at the most, they go maybe a foot rising or lowering. Also, there is pumping through that river on weekdays, but they don't pump on weekends. So doing it on a weekend is the best bet. So you've got this river, and next to it, you have a couple brush, some rocks and some brush, and then up a little higher, you've got a road. So you've got a little bank, and then you've got this road here. So this road is in total 3.88 miles long. And this is what our plan was, and what was easy about it, and what wasn't, and what why I think it's the best experiment that I've seen yet. I would say by far, best experiment that could at least make me walk away saying, okay, well, the Earth curves. The Earth, it must be a ball. What we did is we constructed white panels, and we're going to go ahead and put one here and pretend this is at 1 mile. Okay, and these white panels. Which way do I do these? Like this? Yes. Okay, so we constructed these white panels. They were about 8 foot tall. Okay, so something like this. And they were very easy to determine their height away from the water line. What Enrique had, who was a big help, he had a auto leveler. I'm sure you've seen those before. Basically, the thing would sit on the ground here right in front, take a second to kind of get leveled, and then it would shoot out an array, a beam kind of this way and like this. And we had somebody walk down to the water. They just stuck a 20-foot 2x4 right to the water surface, and then you have this 20-foot 2x4 sticking up, and put it right even with the white. And wherever the ray hits the 20-foot 2x4, which we had it marked off ahead of time, then we knew immediately exactly the height from the water that the bottom of the panel was. So let's say in this example that we're talking, I don't know, let's say it's 6 feet. Okay, so now we know that we're 6 feet off the water line here. And then what we did is we cut 6-inch holes, and say we go, this is 6, so let's say we go 6 feet exactly from the bottom, and we cut a 6-inch hole. Okay, so now what we know is we've got this panel, number 1, and the 6-inch hole is at exactly 12 feet off the water level. And then we go to the next panel, and so on and so forth. So I'm just going to take this and copy it. So I don't have to draw it more. All right, so the plan would be, either every half mile or every mile. So if that one's at 1, then you would have one at 2, and you would have one at 3, and then you have a backboard at 3.88. So you would have this one, that's the farthest the canal ends there, or kind of curves off. And then this one here would not have a hole. So this one's just a solid backboard. So what I started calling this is force the line. Thread the needle. Because then what you do, and I'll tell you a couple reasons why this is a good one. We then would shoot the laser from the starting position, and the goal would be to shoot the laser through all the 6-inch holes and hit the backboard at somewhere around 12 feet. The reason this is a good experiment, number 1, is it doesn't matter if the laser is leveled. Okay, so a lot of applications would say you need to level the laser, which again is really to what degree. You can't, if you use a bubble leveler, okay, it looks level, but is it level? Somebody could say, well, it wasn't level or was level. Well, this doesn't matter, because regardless of if you tried to shoot at an angle or whatever, it's not going to matter. You can't thread the needle if you're not on a flat Earth. The Earth has to be flat in order for you to hit every single hole and hit the back wall. And again, that's a long way for people who don't quite understand. 3.88 miles is not a short path; it's pretty long. But what we kept happening is the beam was too wide as it got to these panels, and it would hit the walls, causing then a interference pattern, which then you would see, like something like this. And we weren't even able to get to this back wall. That's because we were using a couple $100 laser. Now, granted, for the ones I've seen online range from $7,000 to $12,000, something like that. That supposedly say that they can hold the beam What I would like to see, since these holes are 6 inches circle, I would like a beam to be guaranteed to hold less than 3 inches for the entire length. And if any laser company would guarantee that, then that's something I would heavily consider buying, but they need to guarantee it. Meaning, if it doesn't happen, then I'm not going to pay for that laser. But if they'll guarantee that over 3.88 miles, we'll get that, that'd be awesome. So the reason this test is so good is because basically, if the Earth is curved, then there's no way you can thread the needle. And if the Earth is flat, then there's no way you can't. So it really, it has to be definitive, in my opinion. If I get out here and I'm trying to shoot this and we keep shooting and for some reason we keep hitting this third panel up high, that is a sign that it's time to go back and check your distances from the surface of the water. If it's right, the Earth is curved. There's no other way to look at it. Same thing, if you shoot this through all holes and hit the backboard, well, you can go check your distance from the boards again, but it's impossible on a curved Earth. It just is impossible. It means that the water surface is not curved, which is why these distances are allowing a laser to go through it. Now, people can start to say, well, the light can bend. Well, that's just impossible because we're not setting these up at like the exact points that the curved Earth would curve. These are just set at 1 mile, 2 mile, 3 mile, 3.888. So there's no way that you could have a curving perfectly beam that just happens to be going in through each hole. I don't think it's possible. Also, for those people that were there, they know that if we get somebody on the other side of this lake or even further, it would be great to get some drone footage looking at the entire stretch. Nobody did it when we were there, but because they'd have to be quite a bit of ways from where we were, but to get that whole 3.88 miles across. But that would also be awesome for anybody who said that the beam was bending. It might be something we could see. And again, if there was any error in the laser light, which I haven't personally seen happen, but if for instance we basically can shoot through these holes, and one time we hit high, but then I just turn the laser and then I hit it to the right, and then I turn the laser again and it hits low. Well, then what's happening is the laser light is something's wrong with the laser light. And again, that's hopefully when you're paying that kind of money for a laser, it should be well collimated and not have any deviations like that. And then putting it on some sort of a nice, either rented or purchased astronomical mount so that it can be controlled remotely and maneuvered. And that's basically what I think so far is the best experiment. It isn't, I guess I could see where people say it's an optical experiment. I don't look at it that way because it doesn't matter. It's not a matter of you need to be looking, and somebody might say, well, I see refraction, I don't. You have somebody here with a camera that says, yeah, the light's hitting bingo right at 12 feet. Or they say, no, this light is hitting at 18 feet. And over the course of 3.88 miles, I believe that the drop was about 8 to 10 feet. So really, it'd be impossible to make it through the third panel, and pretty damn tough to make it through the second. I could see somebody maybe possibly finagling it so that there was a way to squeeze these two through, and then you're never going to hit this one. It's on a curved Earth, it's not going to happen. So this is the kind of experiment, like I said, if I was out there, I would say that if I could not thread that needle, the first thing I would do is check the distance to the water, and if that's not wrong, then there's, that's it. Especially if we've cut the panels and had the circle cut ahead of time, and we knew the height away from the bottom of the board, check our numbers, and if that's it, I would walk away from that experiment and say that the Earth has curvature. I don't think it's the case, but again, is this an experiment that all globe believers would just continue on believing in Spaceland? I don't know. Maybe that's possible, but it's the kind of experiment that I think you could tell somebody to repeat. And for me, it would be that kind of definitive test. If I could thread the needle, boom, I'm done. I'd walk away and say, I've already proven it. It's been proven. And why I may think that I have proven it, do I believe that the Earth is flat? Absolutely. Does that make it true? Not at all. But what I say was, I believe the Earth is flat would go to, I've proven and I may have thought, or I may think in my head that I've proven it to myself and that, it's true by everything I know. Well, globe believers would say the same thing. So obviously one of us is wrong, and it's just a matter of a test like this to prove which one it is. So anyway, write to me at bit.ly if you think there's something you can improve here or an idea. Let me know. It could be any other variation of this. I don't know what you think might work and what might not. So let me move on to, let's see, was there anything left on that checklist? Let me double check. Somebody's saying how much it would cost. Says pretty expensive. 4,000-foot rolls of high tensile wire. I don't think that wire would work. I'll contact that person. The company test would consist of placing metal rods in the ground, straight line. This will work. Let's see what this guy's got to say. Somebody's got a YouTube video here. This says, this will work. I actually have the appropriate credentials and experience as a scientist. I am trying to help. If you have any doubts whatsoever as to the validity of this test, please ask. Okay, let me check here. And, all right. We're going to check out this video. 1 second, I'll bring you with me. I know you're not watching what I am. But let me, oops, that's not where I want to go. Let's see here. That one's not going to work either. Scared me. Thought you weren't listening to me. Let's see here, where are we at? So we'll go here, try this one. Let's see what we get. Hopefully he doesn't mind that I'm playing his video. It says, sympathetic scientist to flat earth describes a simple experiment that virtually anyone can perform. Hopefully it's not the same as flat earth maths ideas. Holy smokes. After saying I didn't want any optical experiments, he's like, all you have to do is go out on the equinox and see where the sun rises. Something like, dude, did you hear what I said? Let's see what this guy's got to say. I'm going to bring you over to him.
Like, should you be able to notice the horizon dropping? And the number of degrees is pretty small, like even up in a plane, right? However, if the number, it doesn't matter if the number is small. What matters is do you have equipment that is sensitive enough to measure it, okay? And check this out. This is pretty neat.
Typical science call right there, man. You ever want to know a scientist, whenever they say, now check this out, this is pretty cool. Now, this is pretty cool. They're about to bullshit you to no end. Let's see if I'm right.
Typical camera, let's say. 35 degrees field of view and has 4,000 pixels in the vertical, okay? If you go up 800 feet, all right, which is the height of a...
So I'm not going to watch this further, and I'll show you why. When we get to this site I'm going to show you, which is done by scientists and peer-reviewed papers and all that stuff, they all claim that it's impossible to see where the horizon is. That is not a line that you can say is dropping, oh, it's this low, oh, it's you go up this high and the horizon drops this much. It may appear to drop that much, but there becomes, the further you go up, the more you can see, but with the more distance, the limit that you see. So you kind of, it's like, you're going a little bit, giving a little, taking a little, but the horizon just melts in to that, that point of vanishing point, if you want to call it that. So we'll look at that and let's see what else he's got to say. But if he's talking about just simply measuring that the horizon drops, no, nobody's saying that it doesn't.
Skyscraper, like 75-story or 60-story building or something like that, which they have those buildings everywhere. If you calculate how many degrees should the horizon drop at 800 feet, that equates to 57 pixels in a camera. You should be able to measure that.
So again, what those experiments are is they're optics, where we just have somebody telling us what that means. If you see it drop this much, it means that the Earth is a ball. No, it doesn't mean that the Earth's a ball. It means that optically that drops. So there's lots of other reasons that could happen. And this is the thing, is that all the globe proofs are like, if you go out on an eclipse and you look up at the moon, you'll see the curvature of the Earth. And that curvature of the Earth proves that the Earth's a globe. All their things are like that. It's always that's the proof. And why we can't just say measure the Earth that we live on, measure its curvature. They don't want to do that. they want to keep very local and do.
In fact, I think anybody should be able to measure this.
Okay.
Now, I just want to say this, that you can probably convince yourself with a level and a camera, maybe a tripod, go to a nearby city, get up onto the roof of a tall building. You should be able to convince yourself if the horizon has actually dropped compared to when you're on the ground.
Oh yeah, I don't want to listen anymore. Because again, I said no optical experiments, and this guy comes back with an optical experiment. But not that I think something's wrong with optics. I think that it's not proof, and a lot of us are looking for proof. And I think that when you teach 6-year-olds something so fundamental, that there should be plenty of proof. There should be a lot of it, not just evidence, because evidence doesn't mean anything. I mean, finding Henry's shoes at the murder scene is evidence, but it's not proof that Henry committed the murder. So it doesn't mean, yes, is there evidence that the Earth's a globe? Sure. Just like there's evidence that the Earth is flat. Sure. Is there proof? Well, that's what we're looking for. And looking up at the stars and saying they twist this way and this way is not proof of where you live on the ground. There's a lot of things that could be happening. We don't even know. What if there are 2 or 3 or 4 celestial spheres of stars up in the sky? I mean, we don't know. So it's not proof. And that's the difference. So let's go to this website real quick and check this out. I'll show you what we got. And is that this one? Let's go back to this one. All right. So check out this website. It's really cool. It's really, really great, really fantastic. Basically, the website is aty.sdsu.edu/explain/simulations. And I'm going to leave all these links in the description. How I found it, I got lucky, and wait till you see all this stuff. So basically, you've got this guy, he must be a teacher for San Diego State University, who simulates all these inferior mirage sunset. Let me make sure you're actually seeing what I'm seeing. Oh, you can't see that. Let me move you over a little bit. Hold on 1 second. You are not seeing the whole picture. Okay, move. Let me shrink this down a little bit so you can see what I'm seeing. All right, that's better right there. All right, there we go. So now you should see the shrinking sun, the inferior mirage sunset. So a lot of people have seen this and have a hard time explaining it or understanding it. And this guy refers to scientific papers and other writings, books of what exactly is going on. So, here it says, even if you stand back to get a naked eye view, it's clear there's a little green bit at the end of the sunset. But before we take a closer look, notice some special features of this type of sunset, some of which are very well known in a series of photographs taken by George Kaplan and displayed at the Naval Observatory website. First, there's the reflection. So every one of these words is linked. So you can click that and you'll go over and you'll see exactly what's going on. And you can kind of go through this step by step and really learn real quickly everything that's going on with the sun, with these layers of reflection, refraction, layers of atmospheric effects. And a lot of people need to do these, like Soundly and other people who have laughed when people have said that there's magnification. This guy explains the exact theorem and the paper it was written in and exactly the proof for things like atmospheric magnification. And they laugh at that because, of course, they don't know. These give the web the shape like a capital letter Greek omega. He's got people's names. When you click one of these people's names, you can end up at this, which is the greatest resource I've ever seen. So this whole page, and let me scroll all the way up here. So this is an annotated bibliography of mirages, green flashes, atmospheric refraction, etc. So we're talking all of the elements that are causing things to be seen going over the edge. All of the elements that are causing things over water to look like curvature. All of the things that are causing sunsets to either look like they're setting perfectly or look like they're disappearing into the sky. And you'll see here that as you go through, and I'm just scrolling here, and if you can see the scroll bar on the right, I'm not sure if you can, this goes on forever. I'll start dragging this down. You can watch the text on the left go by, and it will 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 go by forever and ever. And each one of these is like a book, and he tells you exactly what book or what paper. So, C. Mather in the Magnalia Christi Americana, books 1 and 2, edited by Murdoch, Cambridge Press, 1977. And then he goes through talking about exactly what he says in the book that has to do with this particular issue. Talking about phantom ships, Fata Morganas, talking about Fata Hermosas, all the different mirages, inferior, superior. So I was just stuck on this all day and finding out so much stuff. So then what I did is I searched I'm going to search right now, Control Find, and flat. And I noticed that as we start going through, number one, there's 89 words flat here. And as you start going through, you'll notice that there's a lot of people who believed in a flat Earth. His explanation for the two-image superior mirage is exactly the same as Wegener's, apart from using here a flat Earth, because of omitting this vital detail, he fails to understand how a third upright image can be formed. And then it lists the book. And a lot of these I tried to find. Some of them I couldn't, I wasn't locating. Maybe just need a lot of people working on it because I can't do it all. This person here says, talking about the flattening of the moon at the horizon. We've got flattened, flat part, flat top, flattened top, flat top chest, flat level top. So this person here, flat Earth, earliest demonstration of Fraser's theorem by Edward Sang. He thought Vince had seen a sloop floating on a calm sea with a shadow in the water and imagined the rest. Flat Earth, first derivation of the flat Earth model. No sun, moon, and star could have been seen at a lower altitude than 1 degree 22 minutes. All light reaching the eye from the lower elevation must have come from some terrestrial object. Goes on and on through all these. What was that one? Yeah, it says flat Earth model. Flat mirages. This is a flattened image. This one here says a crude empirical approximation for the temperature profile over a hot surface is used with no physical basis. The index of refraction must approach a constant at heights greater than about 2 meters, and of course the Earth is flat. So this is a physicist. This is a paper from J.F. Davis and T.B. Greenslade Jr., Computer Modeling of Mirage Formation, Physics Teacher 1991. They touch on the horizontal ray paradox, pretty dismal. So, this guy, he's a teacher, so he's dismissing the people who are talking about flat Earth. But he's still noting them, so at least he's being honest to do that. Talking about things that are drawn absolutely flat. And I'm just at 22 right now of 89. So here you go. Refraction, his illustration on page 358 shows a flat Earth. So lots in here, and these are all, like I said, books that you can look up. They're probably at archive.org, some of them. And let's go back and see, because this could go on forever, never, never. You'll see that these are all the words flat. And I didn't even, that's the only word I've searched. So, other words that you could look up, mirage. And he describes them really well. Now, these are the books. So, what he's describing here, he's talking about what they wrote in the book. This person here, W.H. Len and H.L. Swartsky. Image transmission under Arctic mirage conditions, says crude mirage calculations, many a reinvented wheel here. They start with the flat Earth model and fudge in the curvature instead of using the exact relations. How about that? Down here we got nice treatment of flattened sunsets, flattening. Here we go again with, he then misformulates the problem so as to obtain a cycloid for the shape of the ray path in the flat Earth approximation. So lots of interesting info in here. Talks about more flat assertions. His instances on the flat Earth approximation leads him astray from the correct explanation of multiple images, mirages. And again, like I said, he's a teacher. It's not like we're going to find someone that says, oh, I believe in the flat Earth. This person here, flat Earth assumed by E. Kular and K. Thiergen or something. I don't know, whatever. So lots of stuff in here. And then let me go back here because I want to show you what else is on his pages. So you can go to this introduction page, and it goes through. I was reading through this. I mean, you get so lost because it's explaining all of these things that I've seen so many times. I don't know what they are or how to explain them. And now this entire website is explaining inferior mirages. And again, they're going to show the ball, but a lot of these, of course, the Earth is never like this, right? So they may show that, but that's not the way the Earth acts. And you can, use your head. And actually, he says something really great at the beginning, or was it at the end? I think it was at the beginning. So he says here, let me see if it's still there. Well, wherever it was, he said that, to not just trust him, but to read the book yourself and don't just, take his word for it. And he may not like a book or may not like what it was talked about, but go read the book, read all about it, and don't make your own, or make up your own mind. Don't listen to him. So I think that's great when people say things like that, because that's great. He's just saying, hey, and he's put all this stuff together unbelievably. You can go here to alphabetic index, and you'll see that you've got accuracy of sunset predictions, and then Aries. So you want to talk about Aries failure, you go here. This whole thing is about Aries. Back out to altitudes of distant objects, angular units, animations of green flashes, artifacts and pictures. So click there, and now you've got halos, you've got light, different light effects. And there's just so much written here, and all these words are clickable. So here's a crepuscular rays. These shadows, he's going to talk about them. Different web pages it'll link to. This is the crepuscular rays assortment, sunbeams, lots of photos throughout this whole thing. And I just think it's awesome that this is probably the most misunderstood element, about flat Earth, that I think that it's just really tough to learn all about the different gradients and how it works. And I learned a lot just today and just reading through some of this about what we see and what these guys think, when things affect other things and when they don't. Avoiding eye injury, looking at the sun, but not bending. So, bending of refracted rays in air. Reading about that. Magnification theorem. So this is the one I was talking about. Talking about the fact that there is the magnification at the astronomical horizon depends only on the density gradient just below the eye level. For practical purposes, that density gradient depends only on the temperature gradient. This page is devoted to demonstrating the truth of this statement. So the next time Soundly tells you there's no such thing as magnification, you can come right here and he'll lead you to different papers. Here's a paper written 1799, 1836, proving these things. So good to go through, read them, at least understand what they're saying, and I think it'll make for a better argument when you're trying to make these points. Or at least, again, it could be talking to myself. Better argument for me when I'm making these points. Talks about Cassini's model. In the books, you can see all the writings from Newton to the first astronomer royal. What was his name? Halley. No, Halley wasn't the first. Flamsteed or something like that. Yeah, and reading the letters back and forth to them. Here's calculator for altitudes of distant objects. So you've got calculations here, the algorithm. Basically, we've all seen this before, right? And I didn't even get to this page. I wonder if he uses the same 8 inches per mile squared. Oh, look at this. We've got, please enter the temperature and height of the observer. So this is something I've never seen in a curvature calculator. Just first time I've seen this. Looks like you enter a temperature and then height meters. So please enter the temperature at the height of the observer. So let's do like Canagau. So maybe it's 70 degrees. Height of 1,000 feet. And at the temperature and height of the target. All right, let's say over there, Canada's really cold. It's 40 degrees. And height is 9,400 feet. Please choose how you want to specify the lapse rate. Either click this button to compute the lapse rate for the temperature and heights above, or put the lapse rate in the box. And then we get something degrees per kilometer. Anyway, shouldn't do this live because I never looked at it before. Remember that thermal inversions correspond to negative lapse rates. The script will complain about lapse rates that exceed the adiabatic value of 10 degrees per centimeter. So it says, having determined the lapse rate, we find the ratio of curvatures of horizontal rays in the Earth's surface using the equation below. Actually, I include the additional factor of something. Your values, k equals corresponding to a radius of curvature. Please enter here your favorite units. Target distance. Finally, we find out the aptitude. So yeah, lots to do in here. I would have to look through all this, know what the hell I'm doing. You can go into the looming page. Talks about when items are looming over the horizon. And again, it's just good to learn exactly what these guys think. I'm not saying that everything that they say is what I believe. That would not be true. Lots of mirage simulations. There was a whole page of little video simulations. I'm not sure where I was. Standard atmosphere, altitude at the observer, minutes of arc. Here's a ray diagram. I've seen these before. They are good to look at. Oops, did I not go there? I found a broken link. I can't believe it. This is another good thing. This is a atmospheric optics glossary. So all the words that that we should all know what a duct is. Extinction, I didn't know what that was till today. But this is interesting. It's the loss of light in the atmosphere. So just like we say, when you can't see forever, that's exactly what extinction is, that you can't see forever because you've got the loss of light because of the atmosphere. Extinction is the sum of the actual absorption and scattering. Talks about a fata morgana, geodesy, geoid, geometric horizon. And again, one of the things I've talked to people about before that they don't seem to get, I don't know if this person does, but globe believers seem to think that the horizon is a physical thing. It's like a physical place where the Earth curves away from you or something, and it's an optical thing, which we know by the fact that things all disappear at the horizon, railroad tracks converge at the horizon. That's because it's an optical effect, not a physical effect. And one way you can look at that is picture you went to the moon. Let's pretend that you can go to the moon, and you go to the moon and there's railroad tracks there. Would the railroad tracks end in the distance by converging to a point like they do here on Earth? And in my opinion, the answer would be yes. There would be no reason why they wouldn't. Well, if you're a globe believer, then that is not the case. You would have to believe that railroad tracks would go and come kind of close to meeting, but then they would just end because the curvature of the moon would happen quicker and more abruptly. And therefore, since you believe on Earth that the railroad tracks happen to end right where the curvature is, then on the moon, they would have to end earlier and abruptly and then go over the edge. You wouldn't see that part. So, or you can be a flat earther and recognize that that's an optical effect and has nothing to do with the ground. Let's see what he says. Horizon, an ill-defined term used in many ways. See apparent horizon, astronomical horizon, geometric horizon. To an astronomer, one of these horizons is a collection of directions in space, and in fact a circle on the celestial sphere. To more other people, the horizon means the edge of some physical object. Then it makes sense to speak of the distance to the horizon, a usage that seems absurd astronomically. Horizontal refraction, the astronomical refraction at the astronomical horizon, not refraction parallel to the horizon as non-astronomers might suppose. So lots of stuff in here. He seems like a very honest person, whoever wrote this thing. I don't see him, many times saying things I don't agree with, or it just seems like he's honest. Mock mirage, an inverted image produced by a thermal inversion below eye level. Caution, terms like mock mirage and pseudo mirage should not be taken to mean that these phenomena are any less real or any than the classical inferior or superior mirages. The names are chosen simply to distinguish them, the recently understood mirages, from the classical ones. A mural mirage, what is that? Non-shapituling, I have no idea what that is. Optical death, perigee, pseudo mirage. So lots of words in here that you can learn. Towering, we've heard that one. Zenith distance. So I think this is a good place to go. And again, this is the glossary of common astronomical terms from Harvard. So there's lots of links in this thing just to, I don't know, I think it's kind of a great starting point if you're going to be looking into the atmospheric effects that really we see every day. And they're so, think about in school, were you ever told about anything about atmospheric effects? I wasn't. Clear. And these things are so clear to me now, like why they wouldn't tell you. It's just like why they don't tell you about the flat earth in school, or why they don't want you to think about it. It's just simply they don't want you to think about it, because the more you think about it, the more possible it is for you to realize that what they're telling you just doesn't work. They want you to just be quiet, just believe it, and move on. They don't want you to do projects or something like that on the shape of the earth. So same thing with like these kind of things. I just wasn't taught about all these things, and they affect you every day. When you see the sun disappear, when you see it kind of fold into itself, they still call that refraction. They believe in, for the most part, that you're seeing a sun that is beyond the horizon. It is below it, and you're seeing it up above. So when did science start believing that you can see around curves and you can, like magic, that the sun is behind the curvature of the earth, but you're seeing it up in the sky? Just like the mountains at Canigao and those kind of places where, that's what they have to believe. That's what is so crazy to me is that Canigao from Alosh. Just bringing this one up because I think it's a good one, but also to just look at the images and then to believe that these things are being lifted up. That these mountain ranges here, are these being lifted up, the entire mountain range? And when you watch these videos, if we go watch a video, we're not seeing we're not seeing these things shimmering or oops, let's sound off. All right, let's see here. So we're not seeing these things flickering. This is not a mirage, and that's why many people, look at, let me get you on a better view. This one here. So watch here. We don't see anything here. Now this, on a normal day, people are going to look at this and they're going to come to the conclusion that this is the horizon line It's a physical separation between where the Earth ends and it curves over, and that's as far as we can see, period. But on this specific day, the sun gets behind and creates a silhouette. So you'll see that coming up here shortly. And the fact of the matter is that these mountains are not floating and levitating in the air. They're just not. They're not a mirage. Doesn't have any of the characteristics of mirage. There's no towering. There's no floating. There's no distortion. There's nothing. That is the mountains of Canigao. Now, when you hear people say, oh, it's just this mountain here, this peak is 9,000 feet, but the rest of the mountain chain is there. So granted, can you see down to 1,000 feet or down to the shore? No, because you're looking over a vast amount of water. And again, reading these things that I read today are just more backup of that, of exactly what's going on here. But here, if you look at, this is not a mirage. You'll see this is not rising. This is not shimmering. This is the mountains of Canigao. And if you put in the curve calculator here, an eye height of 1,000 feet at that church in Alash and a target distance of 175 miles, you get a hidden feet of 12,380. The mountain peak of Canigao is 9,400. So you're talking about 3,000 feet. These mountains should be the very tip right here, should be 3,000 feet below the curve. So what do you believe in that's floating these to the top? What is lifting mountains to the top? It's just not what they say. And so, for me, I'm not going to just take their words. Oh, this is okay. Yeah, must be an astronomical thing. The sun's lifting thing. The sun doesn't lift mountains up. If these mountains are behind the curve, I wouldn't be able to see them. I cannot see through ocean water, and the sun is not a magic ball that lifts mountains up over water so I can see it. It's just not the way it works. So, and this is not a mirage. That's what they want to try and call it, because there's no other excuse for why we're seeing things at such distances that we shouldn't. And there's still people who go around and tell me that every observation that we see matches perfectly on a globe. That is an observation, and it doesn't match the globe at all. In fact, it would be impossible on any globe unless you believe in floating land and levitating mountain chains. And I don't think that's a good thing to believe in. Until they can show, well, where's the evidence of that? Show me evidence of things being lifted and not that evidence. You can't say, oh, this is evidence of what I'm telling you. No. Show me evidence that things can be lifted from beyond curves and shown to you. It just doesn't make any sense. Why do boats go over the edge then? Shouldn't they be lifted up and shown to me at the horizon line? I don't know. It just doesn't float with me. And there's lots of videos of this, different times of year or different views, maybe from different places. So, this is my video. Hey, good job, Mick H. So yeah, I just show from where you are in the, Google Earth. Hello? Oh, that was a good one too. So, and yeah, a lot of these are telephoto lens. They're zoomed in, but the mountains are there. Regardless of what your lens you're using to zoom in there, it's just like boats over the edge. It doesn't matter what zoom lens you're using. They shouldn't be there. These mountains shouldn't be there. And again, people would say, well, but how are they half covered? It's not important. Shouldn't we worry about first how they're showing at all? That's what's important, is that they're showing. You can see that this is hitting the mountains in the back there. So that it just tells us that things go further on than we can ever see. And that's because of atmospheric effects. We don't see very far. You want to hear the funny thing is that we argue about that right there is 175 miles, which is probably one of the farthest distances you can look, right? I think that there's a record of maybe 250 at the most, but you're really not going to see further than that. Unless, of course, you believe that you see the ISS, in which case you can see 250 miles up. Now, if that's not enough, then you can even go further and you can believe in the globe, and you can believe that the moon you see 238,000 miles away. Now, if you really want to get nutty, you just want to go out with a bang, you can believe that the sun you see is 1,000,000 times bigger than the Earth you stand on and is 93 million miles away from you. That's crazy, but let's get nutty. I mean, it's getting hot in here. Take off all your clothes and go outside and realize that globe believers think they can just look up in the sky tonight and see 25 trillion, that's 25, 000, 000, 000, miles into the sky and just see that far like it's nothing. And that's the closest star. At furthest, they can see something like 9 quadrillion billion. I don't know what the number is, but it's ridiculous. 16,000 light years, I think, with your naked eye. So that doesn't match reality. It just doesn't. You cannot tell me that, oh, you go to the beach and you can see 3 miles to the horizon and things start to break up, but just look up a little bit at night, 25 trillion. 3 miles is tough because at the horizon it gets a little hazy right there, but just look up, 25 trillion. So, and that's just because people told us. There's no proof of that. Just because someone says the stars are 25 trillion miles, and then you walk around saying, I can see 25 trillion miles. This is not smart to me. Sorry, I don't. Where's the proof of that? Just because they have to be? That's another thing we just need to realize, that everything that they say has to be. The stars have to be 25 trillion mile or the whole thing is garbage. So that it's not like maybe there's something. No, they have to be that far or else their entire model is garbage. The moon has to be as far as they say. The sun has to be, 1 million times as big as the Earth. Jupiter has to be 100 times bigger than the Earth. Those things are required for their model to work, and they've just taught us all that it's true. That's it. Again, I keep saying it, but there's no cosmologist, there's no astrophysicist, there's no cosmogonist. None of those guys have ever even been to space. It'd be like we have a bunch of doctors who have never touched a human body. Oh yeah, we gave him an MD and him an MD, and he's a heart surgeon, but they've never touched a human body. What? They need to do that before we give them these degrees, but we just give degrees out because people read a book and they know the facts that they can regurgitate and tell you is true, and you're an idiot if you don't believe them. Well, if there's not a bigger magic trick of all time than that, I'm not sure what there is. It's sad enough that we give degrees in religion, but this is far worse because these people will go around and tell you that it's the truth. Not very many religions will say that. Some do, some don't, but not science. Science is a religion that will shame you for not believing in their truths. Again, every scientist, at least that I can think of, believes that neutron stars, if you took a spoonful, would weigh 22 billion pounds. And if you want to believe that, more power to you. So I do believe that's it for tonight. I wanted to go through the test. Please let me know what you think of the thread the needle. If you like it, if you think we should go ahead with it. Because it's easy setup. The panels are cheap, and we can get that ready to go. And then I could just really start focusing on getting a laser, getting at least a guarantee from someone that a laser will hold that. And then within, I don't know when Mike's experiment is. I want to say he said it's the beginning of next month or something. But he's going to go out and, before he does his long distance test, is going to check the beam at 3.88 miles to see. And if it can be under 3 inches, I think that there's not a better test that really can't be argued. Again, you cannot hit all 4 holes unless the Earth is flat, and you cannot not unless it's curved. So there's really no in-between. It's not like, well, we kind of did it and we kind of didn't. Either you can thread the needle or you can't, and that's pretty much it. Yeah, granted, the laser could have some malfunction or something, but we'll be there to take care of that and hopefully have a nice guarantee that goes with it. So I think that's it, and can't think of anything else I need to talk about. So I just wanted to cover that, and then again, let me know. Go to bit.ly/force the line. And remember, if you want to be a patron, that'd be awesome. Go to patreon.com/jeranism. Got over 200 patrons there. Very cool group. You get into the Telegram group where I'm at every day talking to everybody. You also get on the Discord server. Thanks to all the moderators and Karen B and people that help me keep that going so smoothly. That's awesome. And then you also get a couple exclusive videos that I've done just for patrons. So that really helps me out, and I can keep doing this. I love looking for the truth, and that's what I'm going to continue doing because I haven't found it yet. And so at least I'm open enough to say that if I'm wrong, I'm going to admit it. But I want the test to show it. It's not just okay to just say, yeah, well, the scientist told me that if I see the horizon drop, that's proof that the Earth is curved. Well, maybe it is to him, but it's for those of us who have seen through the things that NASA and SpaceX have shown us, It's going to take more than that. And it's not our fault. It's their fault. You've had 50 or 60 years to convince me that space is real. You've had 60 years to convince me that space travel will eventually happen, that we've put men on the moon, that there's a craft in orbit of the Earth, that the Earth is a ball spinning in space. That's, all these things. You've had the time to do it, and you haven't done it. You've done a shit job of anything that you've done. Actually, it's a complete and total waste of money. $52 million a day. I cannot think of a worse expenditure of money than to keep parading these astronauts around in Jedi uniforms and keep putting them up on the ISS so that they can grow lettuce for the first time for the 13th time. It's not impressive anymore. And with a craft in orbit, at least give me a 24-hour view of the Earth. At least. And they can't do that. So, why not? They've got all these cameras on Mars and Jupiter and show me Pluto and Cassini and all the, show all that, but you can't show the Earth. And it's just ridiculous. They've had enough time to figure it out. It's just like the 24-hour sun down in Antarctica. You've had, how long have cameras been invented? You couldn't put a camera down there and show people? Things like that would be in every school. They would be in every classroom, because then there's no question. If they're wondering, the only reason people are flat earthers is because of NASA. That's it. They're an inept organization that is poorly run, and they don't care. They keep doing the same thing, and they just keep providing nothing to humanity. So until they either I can prove that what they're telling is lies, or they can prove to me that what they're telling is the truth, I ain't going nowhere. So guys, make sure you do your own research, though. That's the most important thing, because if you do, you'll never again believe what you've been taught. Till next time, guys, it has been jeranism. Peace.